Okay, class. Still in chapter 3, I want to talk a little bit about measures of variability. And one of the things I want to talk about is the z-score. So one of the examples that's given to you in your book is around z-score. And this class is predicated on normal distribution. So, as we progress in the class, we'll focus more on z-score and normal distribution, but I just want to introduce the subject right now. So if you see, I have a lot of stuff drawn on the screen. So I'm going to change the color of my pen to something that I didn't use a lot. And let's see, we'll use the green. So z-score. So z-score is measure of variability, and that is how far a data point is from the mean. And so here's our mean right here, mu. We use mu to signify the mean. So we know, just according to statistics, that the empirical rule, and this is the empirical, make sure I'm spelling it correctly. So just like the Blackboard, my iPad does not have spell check. So empirical rule, I think I left out an I. I goes right there. All right. So the empirical rule is that 68% of any sample or data is gonna lie within one standard deviation of the mean. So 68% of any population or sample is gonna lie within one standard deviation of the mean. So 68% here is going to fall within one standard deviation of the mean. 95% is going to fall within the two standard deviations of the mean. And then my handwriting is scribbly on this pad, 99.7% of any sample or population is going to fall within three standard deviations of the mean. Anything outside of three standard deviations is considered to be an outlier. And that it lies in what we call the long tail. So that falls, we'll just call an outlier or something that's out of bounds, right? So z-score is calculated by x minus mu divided by the standard deviation, right? And then according to the empirical rule, this is also in your text, we can write it this way: 68% is going to fall within plus or minus one standard deviation. And I know this is written incorrectly, but I'm just trying to drop a point. One standard deviation of the mean, right? 95% is going to fall within two standard deviations of the mean, which gives you a z of 2, right? One standard deviation is a z of 1. And then the 99.7 that's lying within three standard deviations of the mean gives you a z of 3. And we use basic algebra. So we wanted to determine the upper and lower limits. This is determining upper and lower limits. We would use this equation right here. X is equal to mu plus or minus z times standard deviation. All right, so like I said, I just use basic algebra, solve for x. And this is how we can find the upper and lower limits of whatever we're looking for if we want to. And we'll talk about more of the practical applications of this, but I thought I would use the example that I did previously in terms of weighted average. In terms of average. And so if we go back to this test score, right? And we said you have a quiz score of 86.2. And then I use this Excel formula. This is just plain Excel. And I found the standard deviation, which was 5.167, right? So if I use this formula right here, and I brought it over here. So if I wanted to see, if I took your class and these 5 quiz scores, and I wanted to find out what the grades are within one standard deviation of the mean, I would use this 86.2, right, plus 1 times 5.67, which gives me 91.37 as the upper limits within one standard deviation. And then if I want to look at the lower limits, I would take the 86.2 and subtract 1 times 5.67, and that would give me the lower limit of that quiz, right, being an 81.03. If I were to look at 99.7% of the class filing, within 3 standard deviations, the high score would be 100, right? And then the low score for 99.7% of that population or sample class would be a 70.7. Using the same thing, that would be the 86.2 plus 3 times the 5.167. It gives me more than 100, but for the for the purposes of a course, you can't score more than 100. So it tops out at 100, and then the 86.2 minus 3 times 5.167, right? And that would give me the 70.7. As an instructor, if I had, the average of my quizzes was skewing towards an 86.2, I would probably look at revising things to push it back towards the average being more like a 70 or a 75. That's how things are done in terms of grading. So I hope this makes sense. Once again, as always, if you have questions, please email me.